I can officially say now. The code that is on here is my own. Do not take it for your own projects. That's not cool. This will actually, the code will get removed at the end of this from my GitHub account after this. So the material that I'm using, as far as like the resources, is all on there. But not the code that we're going to use to practice our debugging. And like in real life, this is mostly just to be an example for your own code, for your own assignments. Having to explain it every single time. Cool. So I've already pulled it down, and so in my directory, I can see that I have my folder. I can sign it. I can get on there, and you see a couple files, right? So this is meant to be a talk for pretty much every level of CS here at PSU, up to Karla. We have some 162, 202, 163, and then if you are in 201, I included some code that is written by the Ret2Win people at ropemporium.com. They're really cool. They do CTFs, and so it's just meant to be a good resource to learn how to debug assembly and stuff like that. So yeah, there's also some PDFs. There's PDFs for a cheat sheet that I have right here. There you go. Here's it. We normally try to provide this in the tutoring center. It's normally double-sided, but I didn't do that. There you go, deep. Oh, yeah, good. And then I also have my slides up there. Again, this is the code that you guys see up here is my code. It's just some example code. Don't use it on your own assignments. I'll get really angry, and probably Karla too. So don't copy my code. Anyway, so I provided a Makefile, and so if we go ahead and type make right off the bat, you notice it says some fancy stuff. It compiles all of our code for us, no matter what your level is. If you are trying to do the Ret2Win, you'll have to unzip that, but we'll talk about that if we get through everything. Cool. So we have some 162, 163, and some 202. So let's go ahead and open it up in your favorite editor. Let's look around, right? You can't really run code without knowing what it looks like, right? So let's go ahead and open up for a quick show of hands. How many people are in 162? One person. 163. 1, 2, 3, 4. You're one. Oh, yeah, you're doing the yeah. So let's do this. Let's open up 163. If you open up 162, it's going to look really similar. It's going to be a class, and then you're going to have an array of classes. So as you can see here, I have this set up kind of like the .h files that you guys are used to, but because I'm lazy, I just put it all in one file. And so you can see here that I have my class person with some information down here. Like most people, they have a name, a description, and a char array of 3. That's for the age, right? Most people are probably going to be under 999, so yeah, it's useful. Yeah, most likely. So yeah, and then I have a node, like you guys would be expecting, right? I have it. It's traditionally more of a DLL node, but we're actually going to use it as a CLL DLL mix. So it's going to be a circular doubly linked list. If you don't know what that is, that's totally okay. In your guys in the 162 code, it's just an array. What? I wrote this today, yesterday, but what? You couldn't find the program in the folder? Were you able to do the Git Clone? So this is the Git Clone, all one line. And then you're going to have to CD into the workshop, right? So once you CD into the workshop, you should be able to see all the elements. Is everybody at this point? Yeah? It's okay. Thanks for helping them out. So yeah, we're gonna. So this is the code, right? We have some stuff in here, not anything too crazy from what you guys have seen in 163. We have a list class. That's the thing that holds all the people. It's a store, because stores hold people sometimes, right? If you're talking about like employees. And we have some functions, some recursive and some wrappers, and then we have some helper functions. We have our very small main, because I like to have lots of helper functions, as you can tell. I have some ones that are more for like utility, and then I have ones that are more for my menu. If you notice, I have it set up to be fairly readable. Be like, oh, hey, look. Helper functions that are just regular helpers, and ones that are for my menu. Yeah, and then so I have implementation underneath that. So between giving you guys the source code and using GDB, we're going to go through and debug what's happening inside of this program. Well, first off, we need to see if it's actually working, right? So first off, you're going to want to type make. You could type make and CS163 like this, but it's not going to do everything that you need to. And so just type make or make all, and it's just going to compile everybody's code with the -G flag. If you guys notice the -G flag right down here, this is really important in GDB because this is how we link our source material into our executable, so that way GDB can see what's happening underneath inside the code. Does that make sense? Cool. So does everybody know how to open up GDB? Yeah?
GDB.
Okay. GDB.
Then do you use the -TUI? That's a graphical interface?
We are going to go into that.
Okay. /8. Oh,
We normally do a.out, but in this case, 163, yes, exactly. So we're just going to say CS163, because that's the executable file that we wrote that our 163 compiles into for this case, because I had the Makefile do the work for us. So if you notice, we come up with GDB, right? So what are the basics of GDB? Does anybody know what do we do now that we're in GDB?
You can run the program.
We can run the program, right? So how do we run the program?
Type run.
We could type run. Did you know you can also type just R?
Did not know that.
Did you know that you could say run and pass in arguments to it? So if our program took multiple inputs, we could pass them inside of here. I'm actually going to quit and rerun this. Tput. Reset. Set. That way it's a little bit easier to read the GDB. Cool. So I could type run 1, 1, 2, 3, 4, 5, and the 5 arguments that are passed to our executable, we could do that. But because I don't have a main that takes an argument, so it's not going to do it right now. But we can go ahead and run, and we're welcomed with a very lovely little menu, right? Yes.
Sorry, this is a bit unrelated, but what's the difference between tput and using clear?
I do not know. I just know that's the way that I've been able to actually get it to clear my entire screen. So that way, when I scroll up and down, it doesn't do anything. But yeah, so we have a menu. Welcome. Go ahead and find a seat. You're going to type in this into a directory that you make. All one line. Just with git space clone space this whole thing one line. Or one HTTP link. Cool. So we have a menu, right? So what do you guys want to do? We're not segfaulting yet. We're not having any issues yet, right? So what do we do? What do we want to do?
Add an employee.
You want to add an employee? Cool. Let's do that. What do you want the person's name to be? What? Michael. Like that? Is it AEL to make it Michael? Okay. See, I can't spell to save my life, so this is just what happens. What's going to be Michael's description? You know what? He's cool. Right? And then what's Michael's age? Let's make him 125. He's a really old employee. He's been at Fred Meyer's for a long time. Cool. So that's his age. Cool. So we're back at the main menu. So what do we want to do next?
Edit, Michael.
You want to edit Michael? Oh, let's see. Oh my goodness. What's oh. Well, it took a long time to execute, and then what do we get?
Segfault.
And we get some weird code. What's up with this? So what do we do now? You guys ever tackled a seg fault?
You can backtrace.
We can backtrace, exactly. This is like the bread and butter of like basic GDB. We're gonna run our program, we're gonna choose options until we get to our problem, normally a seg fault, right? And then we backtrace, try to see where this is happening. Cool, so what do we notice about the backtrace?
It leads us through every function.
Exactly. So we have every single function from main at the very bottom, all the way up to the function where we seg faulted. Sometimes what you'll get is you'll get a bunch of functions up here, like in the C library or in the C++ libraries, because you might have seg faulted inside of string compare or inside of string copy or something like that, in which case it will have a whole bunch of, you'll have more functions up here that you don't really care about. So you really want to look for which one of these functions, which one of these functions is the one that you wrote, right? In this case, or I wrote. But let's see, which one do we see anything that looks like something that we wrote? Which one? Check name? Check name, yeah. Is that the function name or is that the class name? How do we read this? So we see check name. What's that? It's the function name. What's this person part?
This is the pass.
Exactly. So we know that this is so what do we know already? Just right now, where is this seg faulting?
Person check name.
Yeah, inside of a person function called check name. Awesome. Well, that's kind of weird. It's seg faulting. And it's seg faulting inside of this function. So let's try to see exactly where we're at. Well, how do we look at where we're at inside the code? L. We can, or list. Ooh, there you go. Ooh. L and list are aliases of each other. So like with R and run. Oh, do you mind letting him in really quick? Cool. Come on in. Sit down. You're going to type in this URL, or not this URL. You're going to type in this command into a directory that you make, and it'll clone it into your repository. You can go there and then cd into the directory that'll get downloaded, and you're going to go ahead and type make, and then go ahead and open up or run whatever class is more appropriate for you. If you're here for 201 stuff, we're going to cover it kind of closer to the end. Cool. So if you notice here, we typed L, and then we typed list. And what did it do? It printed out where we're at, right? We seg faulted on line what? What was the seg fault what was the line that we seg faulted on? Check name is a function, but do we have the line or maybe the file name anywhere? 223, where is that? That's right there. Okay, cool. So we know that we stopped on 223 in cs163.cpp. And if we notice, it doesn't start printing at 223. It starts printing at 218, right? So it's trying to give you some context, right? So we see 223 right here, and we see a function, right? Oh, yeah, look, it's our check name function, right? So what do we notice about that check name function? Well, it's seg faulting here, but it's not really clear why this is seg faulting, right? There's not anything like there's a name, there's a match. Don't ignore the this part. It's not really, I put it in for other things. So how do we figure out what's seg faulting? Do we know? Do you guys know?
Set a break.
We can set a break. That'd be one way. But we have a bunch of functions that are kind of our bread and butter if we're doing presentation. Hey, look at that. This is kind of like our bread and butter of GDB commands, right? We already used a couple of them. We have run. Oh, there's break that you mentioned. We have list. We have backtrace, right? We've touched that. We had frame. That's trying to figure out where in the stack frame we are. Do you mind opening the door for? And then we have print, and then we have some steps, and then we have continue. So which one of these kind of sounds like we're going to be exploring our code or getting some information about our code or variables? Print, right? Because we can actually see what's happening in a variable, right? Well, it says, so we can type in p or print. Here we go. I'm going to type p because I'm lazy. And what should I print out? We're right here inside of check name. We could see what name is, or we could see what match is. You guys want to see what match is? What's match? Well, match is an empty string, but it's not null. Oh yeah, let's print out name. Oh, look at that. What do we notice about that address? It's really low. Right? It's really close to 0, which normally means that we probably accessed something that was at 0 and then it was a little off. So we segfaulted because we're talking about name. But name is part of the person class, right? That's kind of weird. How can we have a person that's at 0 or around 0? Well, let's kind of look at our backtrace again. So check name isn't really the cause of our, it's the cause, it's where we segfaulted, but it's not really the cause of our segfault, right? What's some of the other functions that we have? Well, we have main menu, well, we have main, then we have menu, and we have change employee, we have remove. Well, that's not super helpful, huh? So we're removing something from our list, that's good to know. And then we have check name. Oh, we have 2 removes, right? So what's the differences between these 2 removes? Well, this one seems to have some stuff passed in. We have removed, we have match. But this one, right, we're passing in a head pointer. So what could you guess just about these 2 functions? I know, it's not really fair. I'm asking you guys to tutor me.
It's a wrapper.
Yeah, exactly. This is probably a wrapper, right? Because we see, this one we don't really see anything as far as like head pointers or necks or anything like that. But this guy, we see head. Right? That sounds kind of like it's a recursive function. So we could probably guess that function 2 is probably a wrapper, and function 1 is probably what? Yeah, the recursive helper function, exactly. So which one should we jump to? Should we jump to 2 or 1? 1. That sounds like a good idea. So how do we move to that frame or that stack frame? Well, what was one of the functions in our bread and butter? Exactly. So we're going to use frame, or f, and we're going to type in the number of the frame that we want. Perfect. So we're going to say f1, or frame 1. And now you notice that it says, I know it's really hard to see, but we see line 432, which is where this one was paused, right? This is part of that recursion stuff, right? Pausing execution, going into another function, right? So let's see what's going on here. So we're going to type L, look at what's going on. But you guys are kind of becoming pro now, right? We don't want to just stay saying L. What's some another way that we could probably look at what's going on? Maybe a little more interactive. Anybody know any of the cooler commands? We could type lay, src. And instead of getting all this weird information all the time, we can just go boom. And we can actually walk around our code, see what's happening, and I can move to make it so I can walk up and down my command line too. So we notice that if I type BT here, I still get my stack frame. If I type frame frame 1, I still go to that frame. But it's a little bit nicer to see what's going on, right? It's kind of helpful, especially when you're trying to print out variables. So, well, we're right here. And what do we notice about what's happening on this line? Head arrow data, and we have this weird function called check name, which what would you guess check name to do? Yeah, it's going to check the name, exactly, right? This is why you name functions well, so people can help you debug, or you can help you debug, right? So we said, if head arrow data is match, okay, so this is the line that we're segfaulting here, but why is it segfaulting here? Well, how do we figure out what's segfaulting? Well, you know that name was null, or name was hex 11, right? So what can we print out or try to look at to see more about what's going on? Any ideas? Well, you can print out match, right? But we already know what match is. It's just this null thing that doesn't really have anything in it. It's not null, it's just empty. But what else do we have here? What's another variable that we're accessing right now? Head. So we could print out what? Head. Oh, that's weird. What do we notice about head? It's at address. That doesn't sound good, right? That sounds pretty bad. Okay. So that kind of sounds like we're probably segfaulting we're segfaulting because we're not checking something, right? Well, let's look at our code a little bit. SRC. If you notice, I'm typing folk, which is short for focus. And I'm going to say SRC because that's the source code window. And then now I can move around in here and I can look at my function, right? So I know that this is some weird line randomly in my file. I can scroll up and know, oh wait, it's broken right here. But this is where the symptom is coming up. It's not really the cause of our problem, right? We have all this fancy stuff going on. We have some pointers. Well, that's weird. What do you guys notice? We're checking to see if head doesn't exist, right? We're checking to see if head is null. But we're still segfaulting somehow. Well, that's weird. Well, does that mean that this might be the problem, or is somewhere else the problem? It's probably somewhere else, right? So let's look at our backtrace. We just backtrace. We just looked at frame 1, so where should we go next? Frame 2. Yep, sounds like a good idea. Frame 2. Okay, so let's say, oh, hey, look, we jumped right there. Oh, wow, that's cool. Well, this is kind of weird. This is a circular linked list, right? Most of you guys have dealt with circular linked lists at this point. Where is the what's going on here? We're just calling the recursive function. That should be fine, but it's not. So how do we figure out what is going wrong here? How do we print out what's wrong? Well, we've already stepped into the function because we know exactly where it's happening, right? We know that this is frame 2, and the next frame, frame 1, is right here. This is this function call. So we know that the problem isn't inside of that last function call. Maybe the problem's here, right? What do you guys notice about what I'm doing right away? Well, what do you normally check first before you do anything?
Check if the pointer is null.
I check if a pointer is null. Before I do what?
Before you call or use the pointer or do anything with it.
Before I do anything with it. Do you guys notice where I'm not doing that? Where am I not doing that?
In that function.
In the recursive call, exactly. So we could print out tail. Hey, look, okay, cool. That's where tail is, and we could print tail, arrow, next. Oh no. My next is null. But tail wasn't null. So let's try to print out. This is a cool trick. You can print out the contents of something by going like this, tail. Well, that's weird. We printed out tail, and its next is null, and we have a bunch of garbage data. Name is null. That's not good. And that's just in regular tail. Huh. So is this really where my problem is? I have a node, it exists, but its data is all junk.
We need to backtrace some more.
We can backtrace some more, but we don't we know that our problem really isn't inside the remove function, right? Because we've checked to see if head exists, kind of. We could do a check here to make sure tail exists, but tail is a good value, right? It's this weird variable all up in the heap. Yeah, that's in the heap. So what can we do? What did we do first? What was the first thing that we did when we opened our program? Before we put in Mark. No, not Mark. It was Michael. We called add, right? So this is part of like the debugging mindset. You have to say, what did I do to get to this spot? And that's really the big trick with GDB and most things and debugging is trying to figure out how did I get to this place, right? It's not just backtrace. Be like, how did I get to this point in code? How did this line of code get there? What happened before this line? What happened before 68? What happened before 177? Right? That's why when we go there, if we go to frame 4, whoop, it prints out the code not just there, but also around it, right? So our problem is probably inside of add, right? That's how we got junk data in there, right? Cool. So if we go, let's go ahead and quit really quick. Jump back into my code. If we look at our add function, check name, menu, user readin. We do oh, we have this weird function. Oh, user readin. What's user readin? Well, if we look here, so this is the add function, right? And we look down here, if we look at our helper, where is it? We have our add function right here. What happens inside the add function? We make a person, we read the user input, and then we add it to our list. So if we're going to try to debug this, what are we going to do? We can break after we use the we get the user input, make sure that we got the user input good, right? And then we can break when we're inside of the add function to make sure that we added correctly, right? So let's do that. Sound like a good plan? Cool. So GDB, CS163. Cool. Oh, not FG. So let's go ahead and run our program. Oh, I wanted to break first. So if you noticed, I accidentally ran my program first without putting a breakpoint. Not the end of the world, right? Because we hit our menu right away. So what I can do is I can break my code using Control-C, because that's pauses execution for a moment. And if you notice, I can do backtrace, and we see some of that junk code that I was telling you about at the very beginning. And then we see just our two little tiny functions right there. But we want to break in a very specific spot, right? Where do we want to break? The add function, right? So we had a couple different add functions. Well, there's these cool things that we can do. We can actually break on a function. So we can break on, what was it called? Add. Well, let's see where we're at. BT frame 7. LASRC, because I'm lazy. Frame 7. There it is. We can go up. Our function name was called add employee. So let's break on add employee. Oop. And if you notice, if I go ahead and hit tab, it'll do auto completion for me. Super helpful. There's actually, so let's go ahead and do, oop. Nope, don't want to do that. Nope, there we go. I want to do break, add, employee, right? We wanted to break there. And there was another place we wanted to, there's another place where we wanted to put a breakpoint, right? On the store function. We can do the same thing. We can actually do break and we can say store, : And if you notice, if I hit tab, it prints out all of my functions with the class. Very helpful, especially when you don't want to remember, like, you know, your 500 functions that you've written. So what function did we want to stop at? Add, right? Well, you notice there's 2 add functions. So if I just say store add and leave out the parens here, we'll notice that there's 2 breakpoints. And if I hit info break, we can actually see all the breakpoints that we have. We actually see the breakpoint here at add employee. We can see our breakpoints here at the store function, and we can see that there's 2 of them. One for the one that takes in a person, and one for the other one that's recursive. Right? Super helpful. And it actually even keeps other information, like how many times that the breakpoint's been hit, where the breakpoint is, stuff like that. So let's go ahead and continue. Continue, by the way. Everybody know how to continue? C. Cool. Or you can type in continue. And we were in the middle of our menu. So let's say add, right? So that was A. Pretty sure. Yep, cool. And so I'm in my add function, right? I wanted to skip over this line, right? Because I want it to create itself. So how do I skip over this line and go to the next line? Does everybody know how to do that? N. Why is it not S? What's the difference between N and S?
S is like stepping into a function.
Exactly. N steps over the line. It lets the whole line execute and then stops before the next line does. S will step into any user-defined function. So this would be like the constructor that's implicitly getting called here, or the function user readIn. That's another one, right? That's a user-defined function. So yeah, we're going to hit N for next. We're going to get through this, and then we're going to put in the name. Say Michael again. Mike. No, Michael, like that? Cool. He's cool, and let's make him 12 today. Child labor laws, you know, they're great. And then it broke, right? So let's see why it broke. Where are we at? We're breaking right before our toAdd, right? If I hit Control L, it'll refresh my page to make it look all nice again. You can also do that with refresh, but I like to just hit Control L because then I don't have to remember how to spell anything. So what do we want to do before we jump into toAdd, or the add function? We wanted to print out the value that's in the person that we just made, right? So how do we do that? We can just print out a whole object. We can just say print toAdd. Oh, that's weird. What do we notice about that? But we gave them values. That sounds like there's an error, right? Okay, well let's do this. So we know that we don't really need to continue executing, right? It's not going to help us out any. So let's just we can restart running our program, right? We can just hit R and it'll be like, are you sure you want to start running from the beginning? You're like, yeah, I don't care about what happened, right? And this is actually really cool. If you notice here, I just went to the menu and repaused. If I hit IB, information B, breakpoint, I can still see it keeps all of my breakpoints from the last time I ran this, right? I don't have to exit GDB. I can just rerun my program. This is very helpful. So now we want to do what? We want to break on the person function, right? So break person, : We can look at all the person functions we have, right? We have user input, Our user read in. Cool. And then let's go ahead and continue. We're going to hit A for add, and we hit our add employee. Right? Oh, and it looks all messy. So what do we do to fix the messy look? Yep. Cool. Has anybody actually fixed all the any of the bugs that are in it yet? No? Oh, that's okay. Okay, so we know that we're right here, right? We're at add employee. Where is that? That is frame 0. And we want to step over this, so we're going to do next. And then we want to step into this, right? So we have a breakpoint on this function, so we can actually just hit continue and it'll stop it for us. So we can do BT. We can see the stack frame. And let's step through this, right? So we have our buffer. We set the first thing to 0. Print out a line. So we can probably skip over this. We can probably skip over this. It's all messy looking. We're going to type in Michael. I'm going to actually type in Bob, so I don't have to ask how to spell it every single time. And then Control L. So we just typed in the name, right? That's what just happened. We just got the buffer, and now it's ignoring, right? So we probably we're going to go ahead and do that, and then let's print out the buffer. P buff. Nope. P buff. Yeah, it probably helps if I. There we go. And it has Bob in it, so we know that we got Bob okay, right? And we have this weird user-defined function called Str Copy. What do you guys think Str Copy does? Yeah, it just copies a char star for us. Because this way, we can figure out if we have a problem with copying our strings, right? Which, all of our strings were null, which probably sounds like they were copied wrong, right? Cool. So let's print out name now, right? P name. Name is null, but what's buff? Buff is not null. So where's our problem? String copy, right? So let's break on string copy. str. There we go. CPY. Cool. Let's put in person description. He's cool. The only reason why I'm not restarting this is because I already have a string copy coming up in a couple lines. So I thought, why not? Let's try to figure out what's going on. We have a couple chances, right? Cool. So this is our string copy function. It's pretty small, right? That sounds about right. String copies are pretty common. We have this char delete and takes in a destination and a source. Well, it sounds kind of vague, but it sounds kind of useful because we're doing this sort of stuff a lot, right? We're copying from one string to another. So which one's the one that we're copying from, do you guys think? Yeah, probably source, right? Into destination, right? We have this char delete. It's a little function that just checks to see if it exists, and if it exists, it clears it out. Just trying to be memory safe, right? And then I say if source, what do I do there? I say if source exists, return 0, and then I print out, and then I get all the size. This looks pretty good. All right, so let's step into this. Next. Let's print out source. P source src. Okay, P dest. Cool, dest is null, that's what it should be, right? It doesn't have anything in it. So let's do next. Whoa. Why did it do that?
Source has value in it.
Yeah, because I forgot my not, right? Like, this is something that happens. Most of the errors that are in the code was actually because I just left them in, and I coded it, had an error, and I just was like, this is good. I fail at this stuff too. Okay, so let's go fix that. Okay, so we know that's line, what, 79? So, okay, so FG, 79. So now we can fix that. Well, we're here, so let's common sense some of this. So we have str copy, source destination. Okay, are there any other errors that we could possibly have here? We have string length, get the source. We have our dest. We have our string copy. That looks pretty decent. Anybody disagree with me? Yay, nay, looks good? Cool. Let's run it. So GDB, oh, we have to remake it, so let's type make. Makes all of our code. So if you were doing it in 202, you could run this in 202 and have a little bit more of a complex hierarchy. Cool, let's go ahead and GDB this stuff. CS 163. Where do we want to break? The str copy, right? Cool. So one breakpoint, line 79, 78, pardon me. Whew. So let's go ahead and continue, right? Oh, run. So let's go ahead and add Billy. So let's say lay src. Cool, so let's step through this guy. Have a good one, Tim. Okay, let's pdest, psrc. Cool, so source exists, destination doesn't. So this should be good, right? Let's go in. Whoa, 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 whoa. What just happened there? Whoa, let's backtrace. Well, that's weird. Str copy. But it just went right back into the function. Why did it do that? You guys notice something?
Just have a call.
It's recursive. And this is the most subtle, worst kind of recursive thing to notice, and it's really hard to see. It's the last call in our function, right? Then we have a return 1. This is tail recursive, so it's not going to show the stack frame. So if we continue this, if we step this again, if we hit continue, we'd hit another breakpoint, and another breakpoint, and another. But if we type BT, oh, it still has, we have a couple. There we go. Sometimes it's kind of sneaky to see what's going on. Okay, so we have to go fix that, right? So let's go ahead and quit. Yes. FG 79. Cool. So let's go ahead and we want to break on ST. Let's just break on person. No, let's do add. There we go. Oh. There we go. Let's go ahead and add. Let's do next, next, Billy. Whoa, whoa, whoa. Now it's seg faulting. Seg fault. Whoa, what happened there? So what does this look like? If you had to guess right off the bat, if you see a bunch of calls that look really similar, what do you think happened? What do you think, if you had to guess, what the issue is?
And what's recursive calls?
We probably have something wrong with our recursive call. And if we hit this a couple times, we don't have 152 things. So let's go ahead and try to look at our function here. Let's G. Oh, you know what happened? We didn't type make. Run a Billy Bob 12. There we go. Cool. So we were able to get Billy, and we didn't get a seg fault while adding. That's helpful. So what should we do next? Well, it compiles. That's good. So you want to edit one? Edit an employee? Okay, cool. Let's do that. Still, that's weird. It's still hanging up. So let's hit Control-C, try to figure out what's going on. Right? Oh, BT. That helps. Oh, I think I forgot to actually put in a prompt. Let's hit continue, and I'll say Bob, because I think this is his name. No, Billy. There we go. Well, that's weird. It's still hanging up. Well, let's go to frame 6. Do you guys see any issues? We have a cn.ignore, and what are we ignoring until? Yep, exactly. We missed the \n. Okay, so let's figure out where that is. That was an add, right? Here, let's do this. We can just search for it, right? Hey, look at that. Oh, hey, look at that. I copy and pasted some code. Let's fix that. Got the \n. Oh, that's the wrong \n, huh? It's // Cool. Let's go and run it. Let's add Billy, Bob, 1. Let's go ahead and just display, right? Oh, we've been trying to edit. Let's do that. D. I did not compile. This is the reason why I'm always like, did you compile? Because I never compile. It's it's an issue. Let's go and run a Bob, Billy, 1, D. So let's type in built Bob, right? Whoa. Well, that's weird. We got another seg fault. Same place. That's not super encouraging, right? This is the first error that we had, right? It's like an onion or a parfait. It's lots of fun, right? So let's print out our stuff. We got print name. Oh, it's still 0, 1. Oh, that's not helpful. Okay. Well, let's print out. Well, we know that the problem probably isn't here. So let's BT. Well, let's start verifying things, right? We know that our list object is the store, right? So let's go to where we have store. We could use this variable called this, which if you notice in these class functions is getting passed in. But you guys don't really have to worry about that until you're in 202. So let's go to frame 3 to see our store object. And our store object is called Freds, right? So we can print Freds. I worked at Fred Meyer's for a long time. We have tail and we have count. Count 0. Well, so let's print out what? Tail, right? It's the store object's tail. Oop. So we can't do that. We have to say Freds dot tail. Okay, so Freds dot tail exists. Let's print it out. Oh, look at that. What do you notice? Still junk data. So we still have a problem in our add function probably, right? Let's go ahead and quit. Let's go ahead and look at our, oh, actually I didn't want to quit, my bad. Let's go ahead and break on our add function. So that'd be store add, no. Right, let's go ahead and continue. Oh, run, there we go. Add Billy, Bob, 1. Let's print tail, right? Well, tail exists. Whoa. How does tail exist? Should tail exist? This is the first time we've added to this class, right?
Tail exists.
And tail exists.
What is this up?
But there's nothing in the class yet. We're just now starting to add something, right? So yeah, we shouldn't have anything. So let's print star tail. See what's at there. Oh yeah, that's garbage data. That's not very helpful to us, right? Cool. Awesome. So let's go ahead and look at our add. Where was it? Add function is right. Well, it's not really the add problem, right? It'd be the way that the object was created, right? The constructor. So we can say, we have we don't have a constructor for store, right? That's kind of weird. We have data inside a store, but it's not being set to anything, right? Store is down here. We have tail, but it's not being set. So we need a constructor. Store. And I'm going to be lazy. Don't do this in your guys' code. Tail equals null. Let's go ahead and make. Whoa. Oh, it's because we have the equals. Compiles, GDB, CS 162.3. Right? Cool, so let's go ahead and continue. Oh, run. Let's go ahead and add Billy, Bob, 1. And let's break our program now and just print out where we're at, right? We backtrace. Let's go to frame 7. Frame 7. We're inside of the middle of our thing. That's okay though, right? Lay src. We want to see what's going on. Well, we know that we have our list because our list is Fred's. So let's start printing Fred's stuff. Tail is null. This is a good sign, right? We're getting there. So let's do this. Let's go ahead and continue, right? This is the state that we should be at before we add. Or wait. We just added, right? We added Billy Bob to our list.
Yes. You should have something.
We should have something at tail, right? Darn it. That's kind of weird. Okay, well, let's try to figure out what's going on there. So that means our add function's having problems, right? So let's do this. Our tail is, we can break on our add function again. Yeah. Nope. Break. Store. Add. There we go. So continue. Let's put A. I'm not going to type Bob anymore. So let's print out toAdd. toAdd exists and has data, and his age is 1. That sounds about right. We can see a couple other characters in here because of the fact that it's a static array. That's helpful. So let's do this. Let's go ahead and let's try to figure out where we're at. Oh, it's all messy. Let's do that. Frame 0. Next. There we go. Cool. So we have toAdd here, and we say right away, we say temp equals new node toAdd, right? So let's print. Well, let's do next print tail, right? Or temp. P star temp. Cool, that has our data. That's good. So temp is good. We had not tail. We say tail equals temp. Tail arrow next equals tail. Tail arrow previous equals tail, right? It's a circular linked list. So if we print out next. So we just added to a circular linked list with 2 pointers on both sides, right? So let's print out tail now. P-tail, arrow next. Points to the same place. P-tail, arrow previous. That points to the right place. P star tail. It has our info. That's good, right? That's the information that we're supposed to have. That's weird. Why?
Well, what does that say? the uppercase A mean?
Oh, I just put in that as the name.
A as a name?
Yeah, I just put A as the name. Well, we're passing it tail, but it's not getting changed, right? Why is it not getting changed? Well, how do we pass it in? I didn't pass it in by reference, exactly. This is like literally 90% of the code that I see. It's because of I'm adding a node star by reference. Well, let's look. Is there any other functions that we're adding by reference or doing something to our list, possibly recursively? Yeah, those should be by reference, right? We're not going to have these tails be by reference because these are actually stopping conditions. That's a really good way to do CLLs, is to actually just pass in the stopping condition and you check to see if you're at the stopping condition. And it's really, really functionally very nice to do. So let's go ahead and recompile. Whoa. Oh yeah, because we didn't change it in all the other spots. All right, so let's do this. Add. Actually, let's do store. That's going to be by reference there. That needs to be by reference there. That needs to be by reference there. If you notice here, I call the variables end inside of the functions because it's a little bit nicer way of semantically thinking about what you're passing in. Cool, we compile. So let's go ahead and GDB. Let's go ahead and continue. Oh, run a Bill Bob 1. So let's stop it. Let's print our state. BT, because we don't know where we're at. Frame 7. Print Fred's tail exists now, right? Let's print out what tail is. Tail is a pointer, so we're going to do Fred's arrow, or star Fred's tail, because tail is a pointer, right? And we notice we finally have our data. Oh, and I just quit, apparently. Let's go ahead and hit D for display. No, oh, edit. I think I hit edit. Let's go ahead and run from the beginning. So let's do A, Bill, Bob, 1. Let's just hit display. Nope. I hit edit employee. Let's do Bill. Hey! Oh, we didn't really edit much. Welcome to the person menu. Oh, we selected Bill. Okay, well, what do we want to do to Bill? Do we want to change his name, change his description, change his age, or display him? Should probably display him first, make sure, oh.
It's hello Dave.
Oh, yeah, sorry, I said hello Dave because I thought it was funny, because it's from 2001 Space Odyssey. Let's change his name. Let's put in Bob. Oh, that's weird. Oh, let's see what's going on here. Control C, backtrace. Where are we at? Menu. Anyways. Cool. So there's a couple other bugs that are in here. A lot of them are just little tiny things that are kind of like you have to sit around, play with them, try to figure out what's going on. It's almost 7:30. I don't know if you guys want to stay around longer or if you guys want to bug hunt some more. Do you guys want to bug hunt some more?
I have to stay here.
Yeah. Cool. Well, let's do this. I'm going to talk through some of the commands that I have up on my slides. So we talked about a bunch of these, right? There's some more. There's some more pro commands that we can use. There's a display. Have you guys ever seen display?
Yes.
Yes. So what display does is you can display like an expression like head. And what it does is every single time that you evaluate something, like after a continue or after a breakpoint or anything, what it does is it'll print out that evaluation. So if I print out, and here, if I do, let's go ahead and rerun. Well, let's do this. We'll break on main. Nope, we're going to break on menu. Bmin. And what we're going to do is we're going to disp fun. If you notice, it just says fun is equal to fun. It's not super cool, but what we can do is when we hit continue or run. Ooh. What? Oh, we wanted to rerun. There you go. If you notice, every single time I hit the main menu, it's going to hit print out this fun. This isn't super helpful. Let's go ahead and I'll just type in some junk value. So it's going to print out fun again. Select something else that's not in the list. It's going to print out fun again. This isn't super helpful here, but we could do something where we can actually print out like some more helpful variables. So we can actually do disp, let's say freds.tail. Well, in this case, freds.tail is null, right? And if I hit continue and A, I put in Bill. He's fun, and he's 45. Hey, I can actually start printing out things that are in my lists, right? I can actually even step through it. Let's say I want to break, I want to do break on a recursive function like remove, so store, remove, there we go. And I'm going to hit continue, and I want to remove somebody from the list, and I'm going to have it be Bill. It'll still print out everything that it can. Well, fun was the only one that was universal to everybody, but we can actually print out p match, right? Or we could do disp. Let's do this. Let's do that. Well, let's do head, right? Disp head, and then disp head arrow data. Well, look at that. We can actually go through and hit continue, and it'll print out the information every single time. But because there's only one function call, it's only going to show it once. So that's a pretty useful one. Watch will let you put a conditional break until a variable is changed. So you could do something like watch freds.head. There we go. No. Let's run from the beginning. No. Okay, so let's do watch freds.head or .tail. And it says hardware watch point. We can do IB to print it out. There we go. We can see a whole bunch of stuff for it, right? And we see there's a hardware watch point. So let's go ahead and continue. Right? Let's hit and. Let's put in Shawn. I'm gonna be a little megalomaniac. Bad speller. And I am 28. And if you notice, we hit a hardware watch point. It says old value was this, new value is this, and it tells us the function that we're in. So we can actually use this to even watch for a specific condition, right? If we want to say, wait for something to change. So that's the watch point. We can disable or enable certain breakpoints and watch points using the same command that you see here. Ooh, that's not what I wanted. We can actually set variables. This is probably one of the coolest things that I really like to use when I'm doing CTFs or when I'm trying to print out something kind of crazy is if I do GDB, not that, GDB, CS163. If I want to print out something, let's say I want to print 1 plus 2. If you notice, it gets the little $1 equals 3, right? We can actually print $1. Prints out another $2, and then it prints out the value that was at 3. That's kind of cool. That's kind of weird. It kind of sounds like a variable, right? Well, we can even set our own variable. Set var, let's say $fun equals 124. Well, let's print out fun. Well, that's kind of cool. We can actually do that inside of our program, right? I can actually go through and say, let's break on main or menu. Cool, we're here. Well, let's do this. Let's go ahead and set this equal to, well, let's get the memory at, well, let's just set it to Fred's.tail, right? Oh, nope, I can't do that. I have to say set var $, let's give it a variable. Let's say list equals Fred.tail, right? So now I can go through and say disp list, right? And now as I go through, every single time it's going to go through and print out that variable because that's the evaluation, right? And so if I hit continue, A, Billy, Bob, 1, hey, look at that. Hit menu, and apparently the list is null because that's the value that was at it when I set the variable, right? If I print out Fred's .tail, it's now a different value. So how could I do it to, how can I set that variable to make it so it always updates? I could say set var list equal to memory of, right? Of a pointer to that object. Now I can do disp star ampersand list, right? And now it's updated. So if I hit continue, add again, Shawn bad 1. We have list and we have star lists, and if we print out Fred's .tail, we have star list actually being that spot in the list, right? So we can actually use this in a lot of cool ways. It's also helpful when you're doing CTFs because you can actually just store hex values. You can be like, I want to set a variable called base PTR equal to 0x1 ADFE7. I have no idea what that hex value is, but let's see what it is. Base PTR, P. It is 17,000, no, 176, it's that value right there. Because apparently I can't read. 1,768,935, right? It just does that math for you. If you need to multiply them together, try to do base pointer minus 0x4, right? You're trying to calculate some sort of offset. Or offset times 0x43, maybe it's a really big structure that you're trying to do count down, like go through an array. You can just get the values. It's pretty powerful. Yes?
Does that change when you subtract? Does that change the variable?
No, it does not. So if you notice, if I print this out, it prints out the same value every single time. The only time I can change a variable is by, I think with set, and I might be able to do it this way. Equals 0x0. Yep. So I have to say set. Oh, look at that. That works. A lot of this is just me learning that, and trying stuff out. As you guys can see, I'm like, meh, I don't remember if that works. Let's try it. Right? There's a couple really good resources online for this. A lot of it is on this page that we normally have printed up there, which is on the slides that you guys downloaded. Finish is helpful. If you get halfway through something, realize that everything's cool, you can just be like finish, and it'll continue running your program. Or continue running the function that you are currently executing. So if we look, whoa. I think my computer just locked up. Cool. Finish is a really cool function you guys can use. There's a couple of layout-specific commands that are on one of the slides, and most of it is all the commands are pretty much the same that you have in regular GDB. You guys can read through the slides if you want. There's just 2 more slides. But a lot of it's like, specifically if you want to look at your source code with -G, you can do that. If you want to look at the assembly, you can say lay assembly. There's different registers that you can look at as well, and you can select. That's on the assembly page. When you're trying to debug assembly for like 201, you want to use NI and SI to step through things instead of using N and S. But that's pretty much it. Like, honestly, a lot of it is patience and learning to read the code. Yes?
Is GDB specific to C++, or can it be used on more programming languages?
You can actually run it on pretty much anything that's executable.
Oh, yeah.
So, like, you can actually have it debug LS. So, if I could pull it up on my computer, because it would be nice to, I would. And we could step through some assembly that way, but it's not gonna work right now. Yeah, that's actually one of the cool things too. You can look at the assembly from an output program from like C or C++ without having to object dump it, just by running it in GDB and using lay or layout assembly or ASM, which is super helpful. A lot of it is knowing what's kind of behind the scenes, the class structure that you have and the way that things interact, and then playing around, print out variables, use watch points, use breakpoints, use display, and like printing out variables that you see in your current code space. Anybody else have questions? That was a really good question about pulling other things in. Nothing? Cool, cool, cool. Well, have fun, debug, enjoy. Yeah, the code is like, my computer's just crashed.